Good afternoon, everybody. Can you hear me? Can you hear me? And can you see the whiteboard? MS Microsoft whiteboard. Can you see the Microsoft whiteboard? Can someone tell me?
Yes, sir, we can see. Yes, sir.
Okay. So this is the point where we left. Last time we started elasticity of demand. Then we moved on to price elasticity of demand. So in case of price elasticity of demand, we express it as percentage change in quantity demanded by percentage change in price of the same commodity. Now here, basically, this price elasticity of demand, or in general elasticity of demand, is going to give you more information in quantitative terms. How sensitive your product, demand for your product with respect to change in price of the commodity, that we measure under price elasticity of demand. Then we moved on to discuss about arc elasticity, which we discuss it when there is a considerable change in price. But as I say, even in last class, we give more emphasis on point elasticity, measurement of point elasticity, where we measure it like if P is equal to dQ by dP into P by Q. In certain books, you may find a negative sign. It is up to you. But as the relationship is negative, you may get, usually in normal situation, you will get a negative value. In certain books, to make the negative value as a positive one, they use an extra negative sign. But otherwise, price elasticity is expressed as the first order derivative of your demand function, dQ by dP, with respect to price, means multiplied by P by Q. This is the way that we discussed. And in diagrammatically, if you go on proving it, then another way of measuring elasticity, which is not followed usually, that is lower segment by upper segment. When we measure elasticity at a particular point, it is nothing but lower segment by upper segment. So if in your demand curve, that point is middle of the demand curve, then elasticity will be 1. This is called unitary elastic. If the point is on x-axis, the elasticity value will be 0. It will be perfectly inelastic. If it is on y-axis, elasticity value will be infinity. It will be called perfectly elastic. And in between, say 1 and 0, the value is, it is called relatively inelastic. And here it is called, if it is more than 1, it is called relatively elastic. And we discuss about linear demand function as well as non-linear demand function also, like power function. Elasticity will be, for linear demand function, it will be minus B into P by Q. And in case of power function, it will be minus B. That we discuss. Along with that, for a horizontal demand curve, elasticity will be infinity. For a perpendicular demand curve, elasticity will be 0 in that way. Then we moved on to discuss about determinants of price elasticity of demand. Means the factors which influence your elasticity of demand. Ultimately, it decides whether a particular product will be highly elastic or less elastic. So one point we discussed already or last class, that is your, say, nature of the commodity. Nature of the commodity means if it is an essential commodity, like salt, price increase from 20 rupee to 25 rupee, then also you might be purchasing one kg of salt, suppose, or one packet of salt. So if it is an essential commodity, it is relatively inelastic. But if it is a luxury item, like I mentioned it here, L, suppose, say luxury item, then elasticity value will be your, it will be highly elastic. Suppose 3,000 to 3,000, 37,500, 30,000 to 37,500 AC of your price of your AC increase. So many of these consumer may stop purchasing AC. So if it is a luxury item, it is highly elastic. If it is a essential commodities, it is relatively inelastic. So nature of the commodity is one determinant that determine whether the elasticity, price elasticity of demand will be highly elastic or less elastic. Along with that, another determinant will be, along with that, another determinant will be your availability of substitutes. Availability of substitutes means think about a product, one product is having close substitutes. The moment price of this, suppose a product is there are two products, one is A, another is B. A is having a very close substitutes. The moment price of A increase, what will happen? The moment price of A increase, immediately existing consumer will switch over to its substitutes. So price increase, demand decrease drastically. Demand will decrease drastically because existing consumer will switch over to its substitutes. But think about another commodity like B, like salt. Salt is not having close substitutes. So although price increase, still people might be purchasing a packet of salt. So it is not having close substitutes, so it will be relatively inelastic. And as I told earlier also, simultaneously two products may work, two factors or two or even three determinants may work. Like in this case, in case of salt, what I say, salt is not having close substitute. Simultaneously, might be salt is coming under essential commodities. Because of that also might be still people are purchasing. Some other factor will also appear here. So you are getting a hint actually from that same example. I will bring that issue after some time again. So the issue is where substitute commodities are there, the product will be highly elastic. If substitutes are not there, it will be relatively inelastic. Price increase, demand may decrease, but that decrease may be very, very less, very, very marginal. But think about another product where the product is having close substitutes, it will be highly elastic. So availability of substitute is another determinant. Can you guess any other factor? Can you guess any other factor? Another factor is proportion of income spent after a particular commodity. So I'm giving you the example of salt. Here, even three determinants are appearing. Salt, proportion of income spent under that salt is say 0.00001% might be. So when you are spending a very small proportion of income, it will be relatively inelastic. You are not that much bothered about it. But think about that AC, proportion of income spent is might be 50% of your income, might be. So if this is the case, you are definitely concerned about increase in price of AC because you are spending a say 50% of your income. Here. And here, in case of salt, you might be spending maybe 0.00001% of your income. It may happen. So you are less bothered where you are spending a very small quantity of your income. Okay. So proportion of income spent is another determinant. Any other factor can you guess? Can you guess any other factor? Can you guess any other factor? Okay, I'm not waiting for your answer. I'm rather answering it. But if you like to respond, you can respond quickly. Otherwise, I will answer. 3 determinants I mentioned: nature of the commodity, availability of substitute. Means closer the substitute, higher will be the elasticity value. If it is a luxury item, it will be highly elastic. If it is an essential commodity, it will be less elastic. Proportion of income. If under a particular commodity, you are spending a good amount of your income, high proportion of your income is spent after a particular commodity, it will be elastic. Otherwise, if it is very small proportion of your income you are spending, it will be relatively inelastic. Any other factor you like to respond? Another factor is time. Time required to adjust to new price. Time required to adjust to it, yourself with that new price. Think about this price of AC. Price of AC increased from 30,000 to 35,000. 30,000 to 35,000. 25% increase or something like that. Now, in such a situation, what happened? To adjust with new price, you might be requiring maybe 6 months, 7 months time. Suppose if your income is less, suppose. Then to adjust yourself with the new price of AC, because price increase, you stop thinking about purchasing of an AC. Otherwise, you were about to purchase an AC, but as price increase, you stop purchasing or you stop thinking about AC because you cannot afford that higher price of AC. You will wait rather. Or in such a situation, what is happening? To adjust yourself with that new price of AC, you require more time, say 6 months. Because of that, it will be highly elastic. But think about our salt or matchbox. As I said, simultaneously 2-3 factor also work. But in case of a matchbox, suppose price of a matchbox, suppose it is price of a matchbox, it was supposed 2 rupee. It was supposed 2 rupee. Price of a matchbox is supposed 2 rupee, that increased to 3 rupees, suppose 50% increase. To adjust with that new price, you require might be hardly a few, maybe a second or something like that. Because anyway, behind the scene, what I say, that you are cooking, you are using that matchbox might be for your cooking, only for during that cooking. So to adjust with that new price, time requirement is very, very less. Because of that, it will be relatively inelastic. Because immediately you are adjusting yourself. But if it is a AC, you require almost 6 months time to adjust yourself with that new price. So unless you are adjusting, you are not thinking about purchasing that AC. Because of that, it will be elastic. But in case of a matchbox or any such kind of product where you require very small proportion of time, immediately you are adjusting yourself. Because of that, it will be relatively inelastic. Any other factor? Another is number of uses. Number of uses. Uses of a commodity or number of alternative uses of a commodity. Number of alternative uses of a commodity. So what happened here? Number of alternative uses of a commodity. Think about milk. Think about milk. Suppose you are using milk for having it directly for, there are n different way you can use milk for having tea, coffee or something, for using for curd, then for butter or ghee, or directly you might be consuming it. So n different way you can use milk. Suppose price of milk increase by say 100% or 200%. What will happen? You will try to reduce your consumption in those activities where it is possible. I am not saying that proportionately you will try to reduce it, but wherever it is possible, you will try to reduce its consumption. Wherever possible, you will try to reduce its consumption. So because of that, if a particular product is having number of alternative uses, it will be relatively elastic. It will be relatively elastic. It will be relatively elastic. But think about another item, or maybe, say for example, milk, or maybe even electricity, suppose. Say electricity, number of alternative uses. Electricity, you might be using it for your refrigeration, for lighting of your house, for running an AC, for using a microwave oven, for running television, n number of activities you are using. Now, when suppose per unit price of electricity increased by 200-300%, what will happen? You will try to reduce consumption of electricity in those activities where it is possible. Suppose earlier you were less bothered about switching off your lights or fans or ACs. Then, just a minute. So, in such a situation, what is happening? It may not be proportionately you are reducing everywhere. Wherever possible, you will try to reduce it. You become more careful about, as price increase, you become more careful and switching off the lights, ACs or fans, so and so, whenever you are not using it. So when a particular product is having number of alternative uses, more uses, possibility of reducing its consumption will also be more. Okay. But think about a situation like your matchbox. Suppose this example. Suppose matchbox. What I mentioned. Suppose I assume behind the scene the assumption is that this matchbox you are using it. You are using it, or a lighter, whatever it is. You are using it only for at the time of cooking. Only limited use. 2 or 3 sticks you require it daily at the time of cooking. Otherwise, it is not having any use. In such a situation, what will happen? Although you are using its price also increase, but as it is having limited use, possibility of reducing its consumption is very, very limited. So in such a situation, it may be relatively inelastic. It may be relatively inelastic. Okay. But where possibility of reduction is high, price increase, demand decrease, but that decrease will be drastic. Where more uses are there, that decrease will be very, very high. But in case of matchbox, price increase, demand may decrease, but that decrease may be very, very marginal, very negligible. Or it may not decrease also. So it will be relatively inelastic. So in that way, you can go on discussing those determinants or situations which are the determinants of price elasticity of demand. If you have any question, you can ask me. If you have any question, you can ask me. Otherwise, I am going to discuss another concept of price elasticity of demand. Its use, basically. What is this? So price elasticity, how we express it, is your elasticity, price elasticity equal to dq by dp into p by q. Okay. Or in certain books you may find they are using a negative sign. You may use it also. Okay. Now, remember, there are certain aspects important here. One is One is your, say, total revenue. What is total revenue? In any business, total revenue is P into Q. Earlier also I discussed it. Total revenue, I'm showing you where I discussed it. In different contexts, I discussed it already, even last class, probably. You see here, in our example here, in this one, when I started at the beginning of elasticity, when I was talking about profit. So price of your product increased from 3 to 4, 4 to 5. Sorry, what I mentioned, in our example, price of your product increased from 4 to 5. Cost of production is 3. So per unit, you were making a profit of initially market price was 4, cost of production is 3. So per unit, you were having a profit of 1 and you were selling 1,000 units. So total profit was 1,000. But now price of that product increased from 4 to 5 rupee. All other things are at certain level, means cost of production is at 3. So per unit, you are making a profit of 2 rupee now. But as price increase, demand decrease. So demand decreased from 1,000 to 300. Now you can sell only 300. Some of that consumer already switch over. And you are per unit, you are making a profit of 2. So 300 into 2, 600 is your total profit. Earlier total profit was 1,000. That decreased to 600. This is one possibility. And another I mentioned, 800. Demand decreased from 1,000 to 800. Multiplied by 2, it is 1,600. This is another situation. So while discussing this one, indirectly I was talking about even these aspects. So when we talk about total revenue is P into Q. P is the market price, Q is the quantity you produce. Okay. And if you consider here total cost is total fixed cost, total variable cost. Those issues I will discuss sometime later. But how we express profit? Profit is nothing but total revenue minus total cost. In our example, just now I mentioned what I said. Total cost I said is 3 rupee and market price is 4 rupee I mentioned. Market price I mentioned initially 4 rupee. So this is total cost is average total cost per unit means, and this is per unit market price. So here profit is equal to, here because quantity is 1, because I considered it average, this is also average. So ultimately 4 minus 3 is equal to 1. So per unit profit was, average profit is 1 rupee. But if you bring here Q means quantity you produce, accordingly you can find it out. By multiplying this one, you will get the net profit, you can say. So this is one way. Another issue here involved is that when you talk about total revenue is P into Q. Okay, total revenue is P into Q. Okay, what is average revenue? Average revenue is total revenue divided by Q, is nothing but P into Q divided by Q is nothing but P. This is average revenue. What is marginal revenue on an average? Means this is the revenue. Marginal revenue is first order derivative of total revenue with respect to Q. Means suppose you are producing a particular product, suppose 1,000 units you are producing and your total revenue is suppose 5,000. 1,000 units you are of a particular product, you are producing it. And so Q equal to 1,000 and total revenue is suppose 10,000. So average revenue is what? Total revenue divided by 1,000 means average revenue is 10. P. And total revenue 10,000 is nothing but actually P into Q. P into Q. P is 10. P is 10 and Q is 1,000 in this case. So 10 into 1,000, 10,000 value you are getting. This average revenue is nothing but P. P is 10. This is already you know it, market price. Okay. But what is marginal revenue? Marginal revenue is if you produce say 1,001 unit, and because of that, if you produce 1,001 unit, and because of that, your total revenue increase from say 10,050, suppose 10,050. Then the marginal revenue for the 1,001st unit is 50 rupees. This is your marginal revenue. Means if you produce one additional unit of that particular product, whatever additional revenue you will generate, that is nothing but marginal revenue. Means first order derivative of this one. This is nothing but D into P into Q divided by DQ. What I am trying to show you, I am trying to show the relationship between marginal revenue, average revenue, and elasticity. I am trying to establish a relationship between or among these three. So in this case, you are getting marginal revenue equal to this. Or in other way, if you simplify it, you will find P plus U into dP by dQ. If you bring out this P outside, it will be 1 plus U by P into dP by dQ. Instead of P, I can write very easily air. So I am writing here air. MR equal to air into 1. This portion is what? You see here, dQ by dP into P by Q. Here it is dP by dQ into Q by P. Just the reverse of elasticity. So I can write it 1 minus 1 by E. So this is the relationship between your marginal revenue, average revenue, and elasticity. Okay. Already I discussed some hints I am giving you. Already I discussed earlier. In a demand curve, normal demand curve, what I draw it earlier, middle of that point, elasticity equal to 1. You already know it. Okay. Elasticity value is 1. This is normal demand curve, means this is also your average revenue curve. This is also called your average revenue curve or price line. Basically, what is happening? You can express this demand. You can express this demand in the context of a price line, in the context of a demand curve. Okay. Suppose Q equal to A minus BP. This is a demand function. Okay. Same thing you can express it if you bring this P here, this side, and Q this side, you will get a price line equation. From demand curve you can use it. And this demand is nothing but your average revenue curve, means price line. AR equal to P, you already know it. So P, you are bringing it here and you are expressing it in price line, means this is nothing but your average revenue curve equation. Same thing you will get it here. And mathematically you can prove that this average revenue and marginal revenue curve, MR curve will have a, marginal revenue curve will always have a, your slope twice than average revenue curve. Okay. Marginal revenue curve will have a slope twice than average revenue curve. Because you see here, you very easily you can do it. Okay. Suppose this is your Q, demand function. So what is your total revenue? Total revenue is P into Q. P into Q means AP minus BP square. Q equal to A minus BP multiplied by P, AP minus BP square. What is marginal revenue? Marginal revenue is, what is marginal revenue? Marginal revenue is first order derivative of total revenue with respect to Q. Okay, with respect to Q. Or you need to bring it into price line. You should express it like P equal to A minus BQ in that way. So AQ minus BQ square in that way. You can express price line. So anyway, that I will prove it later on. But what I want to tell you that MR curve will always have a slope twice than average revenue curve. Okay. So if this is the case, because in AR you are expressing it as a price line, so you have to express it in a price line multiplied by Q, you will get your, in this way, means P equal to A minus B Q. So P into Q is nothing but total revenue. Total revenue is nothing but AQ minus BQ square. So this is your total revenue. First order derivative with respect to Q, you will get MR equal to A minus twice BQ. So MR curve will have always a slope of twice B. Twice B means whatever slope of total revenue curve will be, slope of total revenue curve will be, sorry, average revenue curve will be, okay, slope of average revenue curve will be, or demand curve will be, whatever will be its slope, P equal to AR equal to P, you know it already, AR equal to P, this is the slope. So here slope is minus B. In case of MR, slope is minus twice B. So MR curve is always having a slope of twice, then average revenue curve. Okay, now you are bringing it here. Now what is happening, you see here, if elasticity value is 1, suppose in middle of that point, elasticity value is, then 1 means this portion is 0, means entire portion is 0, MR is 0. MR is 0 here. If elasticity value is less than 1, if elasticity value is less than 1, this portion will be more than 1. It is more than 1 means with a minus sign means whole portion will be negative. Means beyond that point, MR value will be negative. MR is negative. If elasticity value is more than 1, relatively elastic, elasticity is more than 1, this will be less than 1. Less than 1 means it will have a positive value. Positive value means entire right hand side will be positive value. During this area, up to this point, elasticity is relatively elastic. It is a positive value. Beyond that point, elasticity value is less than 1. It is a MR is negative. This is happening. Okay. Is it clear? And as I am discussing it, like as I am discussing it, your say like here I mentioned your profit equal to total revenue minus total cost. I am just giving you some hints. What exactly it means? What I mentioned is profit is equal to total revenue minus total cost. Detail I am yet to discuss, but later on I will discuss it. But as it point arise, I am just showing you in a curve. So what is happening exactly? Total revenue is what? P into Q. So you will get this kind of straight line for P into Q. This side is Q, suppose. Okay. And y-axis may vary depending upon how many graph you are bringing in. It may be total revenue, it may be total cost, and so and so. And in same plot, if you draw your total cost curve, in general, I am yet to discuss it to you, but you should for the time being, you assume that this will be the in general shape of that graph. Now, what is profit? Profit is the difference between total revenue and total cost. Initially, when you invest some money, you are at loss because you construct your building, production is yet to start, so and so. But there will be 2 points where there will be no profit, no loss. But if you draw the total profit curve, you will find a curve something like this. A curve something like this. This curve will be your total profit curve, you can say. And when the difference here, you see, if you draw it, this difference is maximum here. Difference between your total revenue and total cost curve. This is the point where your profit will be. This is the point where your profit will be maximum. This is the point. There are different ways to do it. One way of doing it is there are different conditions. Professor Nayak will discuss under market. Actually, you will try to find it out, such kind of values. What will be the level of Q? Suppose Q1, that will maximize your profit under a particular business situation. Price and output determination. What will be the price which will maximize your profit under a given situation? That kind of issues will be discussed. Okay? That kind of issues will be discussed because profit maximization and all this, we usually go for two approaches. Okay? One is your total revenue, total cost, and this profit approach. Another is marginal revenue and marginal cost approach. That I will discuss sometime later, or Professor Nayak will discuss rather. Okay, but as this topic came, I was just trying to give you some of the things because for other subjects I usually teach it for business economics and other, but not here. Professor Nayak will discuss all detail in under market, profit and output measurement. Okay, profit and output determination under different market situation, competitive, monopoly, perfect competition, so and so. But anyway, so if you have any question, you can ask me quickly. Otherwise, I will move on to some other question. If you have any question related to this one, you can ask me, whatever I am discussing it. Otherwise, I am going to other elasticity concept quickly because I will try to finish it today itself. Any question? Okay, if you do not have any question, then I am moving it to second one, that is your income elasticity of demand. Here, you remember this income, this determinant is also coming from determinants of demand. One component determinants was your under demand was dynamic demand function is income. With increase in income, demand for a particular commodity also increase in normal situation. So in this case, how you express elasticity of suppose income elasticity, suppose EI suppose is percentage change in quantity demanded by percentage change in income of the consumer. It is very simple. In other way, you can express it like income elasticity equal to dq by dm into m by q. M is disposable income. M is disposable income. So in normal situation, the relationship between quantity demanded and income is usually positive. So you will get a positive value. By default, you will get a positive value. If goods is normal good, you will get a positive value. But suppose someone is telling you, suppose income elasticity of a particular commodity is minus 0.8, suppose. How will you interpret it? How will you interpret it? It will have a two interpretation, 2 points. First of all, if income of a consumer increase by 1%, quantity demanded of the commodity will decrease by 0.8%. First interpretation. If income of a consumer increase by 1%, quantity demanded for the commodity will decrease by 0.8%. This is first interpretation. Second interpretation is the commodity is an inferior good because income increase, quantity demanded decrease. When you will observe such kind of situation, when the good is a inferior good, it is not a normal good, it is an inferior good. Then only you will find such kind of negative relationship, because in normal situation it is a positive relationship. So indirectly I am discussing also the use of income elasticity of demand concept to determine whether a commodity is a normal commodity or inferior commodity. You can use easily the income elasticity concept. If it is an inferior good or inferior commodity, you will get a negative value. But if it is a positive value, you will get it is a normal commodity. You can decide about the nature of the commodity. Second is, sometimes even this income elasticity concept also help you to predict your or forecasting demand. Suppose, say in West Bengal, suppose if I know income elasticity value is given to me, and I also know the population growth rate. Also I know at what rate population is increasing in West Bengal. Income elasticity value is given to me, and it is also known to me, or it is given to me, that at what rate my income is increasing. Growth rate of income is known to me. If I know all these three parameters very easily, I can forecast what will be the change in demand, say after 5 years. Change in demand for a commodity which I am producing, what will be the demand for this commodity after 5 years. What I mean to say, if some information is given to you that, okay, population in West Bengal is increasing at this rate, suppose 2%. So considering this past population, you can easily forecast what will be the population after 5 years. Income in West Bengal is increasing on an average at this rate, suppose 3%. You can use it as a proxy of state domestic product, SDP, as a proxy of growth in income. Suppose. So you know it from that one that, okay, in West Bengal, income is increasing on an average, income is increasing at 3% or 4%. And if income elasticity value is also given to you, like how sensitive your product with respect to change in income of the consumer, if total population is known to you, if rate of increase of income is known to you, very easily you can predict what will be the demand for your product, say after 5 years. Very easily you can predict. And that will be very, very helpful in your estimation, because you are doing a business. If you assume, because you have to think about expansion of your business, but before expansion, you have to have some idea that if I assume that all other things are at certain level, no change, in coming days, what will be the natural growth in demand for my product? Natural growth in demand might be arising because of increase in population, because of average growth in normal average growth of your income. There will be a natural demand, increase in demand, and you should know it, because overnight you cannot expand your business. If you are thinking that, okay, overnight I will expand my business, you will be in big trouble. You cannot do it overnight. You have to have a plan that this will be my expansion plan. Here will be new building, here will be recruitment process, here will be purchasing plan for machinery and other things. So and so you require a long-term plan for such kind of thing. So here also this income elasticity value may be helpful. And remember, again, I am telling you, earlier also might be I say, this elasticity concept in general, whether it is price or income or any elasticity concept, this will be applicable in other concepts also, which I will give you a hint in production. I will show you how elasticity concept is also even used in the context of production. Okay, this is about, in short or in brief, about income elasticity. Now another is called this cross elasticity of demand, because you remember in our discussion earlier, we discussed about price of substitute and complementary item. When we consider price of the substitute and complementary item for measuring sensitiveness of for demand, concept of cross elasticity of demand is coming into picture. Cross elasticity of demand. What is happening in cross elasticity of demand? So here, cross elasticity of demand, how we are expressing it as percentage change in quantity demanded or say for commodity A with respect to percentage change in, with respect to percentage change in case of price elasticity, what we say, percentage change in quantity demanded by percentage change in price of the same commodity. But here we write percentage change in quantity demanded for a commodity A with respect to percentage change in price of, say, commodity B. This B may be supplement or complementary item. Supplementary or complementary item. This B may be. It is not the same commodity. Because sometime under demand you got it already. Sometime, say, think about coffee and tea. Say elasticity of coffee with respect to tea. How we express it? It will be dq of tea and coffee, suppose. I express it in other way. Tea and coffee, suppose. dq by dp of coffee multiplied by price of coffee by quantity demanded for tea. Two different commodity. In this case, tea and coffee. Suppose tea and coffee are substitute to each other. Sometime in our demand, what I say, price of substitute and complementary item. Sometime what happens? Price of tea may not change at all. It is constant, suppose. Price of tea, no change, constant value. But what happens? Price of coffee decrease. When price of coffee decrease, some of that existing consumer of tea may switch over from tea to coffee because price of coffee is decreasing. They can afford. So instead of purchasing only tea, price of tea, no change. But as price of coffee decrease, some of that existing consumer switch over from tea to coffee. So demand for tea decrease. So in this case, what is happening? Price of tea, no change. Price of coffee decrease because of the demand for tea decrease. So this is a possibility. In this case, although price of the commodity tea is not changing, but as price of coffee, which is a substitute of tea, price of coffee decrease, it become more cheaper. Some of the existing consumers switch over from tea to coffee, so ultimately demand for tea decrease. So it is in same direction it is moving in. Remember. So you will get a positive value. But think about bread and butter. Price of bread, no change. Okay. But what is happening? Price of butter decrease. Behind the scene assumption is that I am consuming bread with butter only. When butter is there, then only I am consuming bread. So when price of butter decrease, butter become cheaper. So earlier, as I could not afford butter, I was not consuming bread also. Now as price of butter decrease, I can purchase butter. I am having access to butter means demand for bread will go up. Because as price of butter decrease, I can afford more price on butter now. I am having access to butter. When butter is available, I started consuming even bread also. So price of butter decrease, demand for bread increase. In opposite direction it is moving. So you will get a negative value. In this case, you will get a positive value. In this case, positive effect. In this case, you will get a negative value. So in case of substitute, you will get a positive value. In case of complementary item, you will get a negative value. Be careful about it. So in this case, what is happening? In this case, so price of coffee decrease, demand for quantity of tea will also decrease. So this is your example of cross elasticity of demand for tea and coffee. So if someone asks you, okay, interpret the, suppose cross elasticity of demand between two commodity A and B is minus 0.8. Interpret this value. The moment you are getting cross elasticity value is minus, first interpretation is that commodity A and B are complementary to each other. Okay. They are complementary to each other. This is first point. Second point, if price of commodity A or one commodity increase by 1%, demand for its complementary item will decrease by 0.8%. This is the second interpretation. So that you should be in a position to explain it. If you have any question, you can ask me right now. If you have any question, you can ask me. Any question you have? I'm closing it here. Let me download the attendance sheet.